Hi guys, welcome to Digital School for You again for the cybersecurity program, and we are learning here for related to the cybersecurity SY0701 exam. And let me share my screen to you what we are going to start here. So in the last session, the most of the part we have completed successfully. We are moving to the domain 3. In domain 3, you will learn about some security features. Here you can see on the screen a domain 1 which we have completed successfully, which is journal security concepts, which is the part of your exam is it covers 12%. If we talk about domain 2, this is 22% major part of the examination SY0701. In this, we have completed threats and vulnerabilities and medication. You can see these in last videos. Also, now just we are moving to domain 3, which is the 18% part of the examination. And in this, we will cover security architecture, and after that we will move to domain 4 in the next video, where you will learn the most or major part of the exam SY0701, in which you will learn about security operations. And it is the 28% part of the examination. Then after that you will move to the domain 5. In the next videos we will discuss about this. In this you will understand the security program management and the oversight, and this covers 20% of the examination. So now we are moving to the domain 3. In this we are going to discuss about security architecture, and in this you will learn about the different methods are there which are related to the security, and also you will learn about cloud computing and virtualization and different architectures are there. Now a domain 3 architectures covers in 4 parts, which is this is what the domain 3. The first we will discuss about security implications, which is 3.1, and the next is 3.2. We will discuss about security principles, and next is what the data protection, and last one is data backup and recovery. Now we are moving to the next. So firstly, we need to understand what is computing architecture. So let's begin at the core computer architecture. This is the design blueprint of a computer system, how the CPU, memory, input output devices, and the data path works together. We have several models are there, but the most systems today use one numinous architecture, where is instructions and data share the same memory. A computer system conceptual, a design, and a fundamental structure, and compose the software and hardware and network resources. And you can say a three-tier architecture separating the presentation layer, application logic, and data storage for a web application, enhancing security and scalability. This is what related to computer architecture. Now we are moving to the next so that we can understand about it. So we are discussing here about centralized computing. What do you mean by the centralized computing? In the earlier days, all computing happened in a centralized mainframe with users connecting through the dumb terminals, and this meant one powerful computer doing all the heavy lifting or the work. And it's basically the mainframe computer is responsible to provide the services to all the machines which are connected into the network. And this was easy to manage. This is what the pros: easy to manage, but cons also there. Cons means a single point of the failure and limited scalability. So you can understand that what is centralized computing. This is a basically model where the data processing is performed on one central machine, powerful computer or a server. A corporate data center where all the company's application and data are processed and stored on central server, and users access resources through thin client or terminals or dumb terminals. This type of network or this type of computing we call centralized computing. So I think you got it, what is centralized computing. Now just we are moving to the next, computing client server architecture. What is the client server architecture? After centralized computing, then come the client server model. First, you need to understand. Client server model is what? Where the central server handles a request from multiple client devices. The server is the machine which is responsible to provide services to the client computers. This revolutionized business system, allowing application to scale, distribute loads, and improve users experience. You can say a network architecture or the client server architecture is where the client requests resources or services from a central server which process and provides the response. Just like you can have an example of that, a web application where the user browsers means what you do, basically you enter the website name, you request web pages from a web server that hosts the website content and functionality. This architecture you can understand, this is what the client server architecture. Now we are moving to the next. This is what, this is related to industrial control system, ICS. Industrial control system is what? Now let's have a pivot to industrial uh, control system. So you can say there are computing systems used to monitor and control industrial process. ICS is what? These are computing systems used to monitor and control industrial process, from power plants to water treatment facilities. They really heavily on reliability, and it works on security purpose also we use, and also real-time response. You can say in simple term, a journal term for the various control system and associated instrumentation includes the devices, systems, networks, and controls used to operate and or automate industrial process. This is what industrial control system. For example, you can have example, a supervisory control and data uh, acquisition, system control, and manipulate, or it is you can say that is also used to provide the water supply, municipality water supply and system monitors. Okay, like the different levels are there, and it's control the flow of it may be the power supply, or it may be the water supply control, the different controls also there. It is what industrial control systems, basically these are the computing system used to monitor and control industrial process. This is what the simple understanding of that. Now we are moving to the next. This is what related to the cloud computing. I think you know about that cloud computing. So for that, we need to move with a different PPT. In this, we have a simple explanation of related to the cloud computing. It may be I have this PPT, so let me share it if it is there. Uh, just a moment. Okay, from here, just we are going to understand what is cloud computing. So it is very important to understand step by step. So you get the information about cloud computing, and you can easily understand this. Okay, here we are starting cloud computing. In this, I'll give you first idea about what is cloud computing. So let's check at yourself that you know about what is cloud computing, and what do you understand by cloud computing. It's most of the people, they do not have idea about that, but this is what the commonly used in the market, and the future of the market where you will use everything will be on cloud after 5 years. Most of the things you will find on cloud only. So that you need to understand what is the cloud computing and what is use of it, and from where just we find it. Okay, so we will understand that cloud computing models, how many type of models are there related to cloud computing, and also evolution of cloud computing, cloud business, who provide basically cloud businesses, who are doing cloud businesses. Now just we are moving, the firstly we need to understand the computing models. Computing models, here you can see we have five models are there. The first is what the desktop computing, second client server computing model, cluster computing model, grid computing model, and cloud computing model. So first you need to understand what is the desktop computing model. Desktop computing model is what, whenever a person work on a single machine, you have your personal laptop, I have my personal laptop. Okay, the people, they have their personal laptop. What they do basically, they store their personal data, they store their professional data, they store some data which is related to their business, and they store it in their personal device. So what they are doing basically, if they want to have a PPT, I have a PPT in my phone, in my laptop. So what I'm doing, I'm preparing PPT in my computer. For what? For my personal use, for my professional use. So what I'm doing, I'm doing desktop computing. If you are a photographer, if you added some video, some audio in your personal computer for your profession, and you store it in your computer, that means what you are doing, you are doing a desktop computing. If any person who manage accounts, and he is using some account softwares to just generate a balance sheet, or if mm, like just he is managing the account of any person, and he's storing everything in their machine, so he's an accountant. Somewhere you find the receptionist, they store the data of the customers in their personal computer, so that whenever they need the company, they need, they can easily send it to them. This is what the desktop computing. So where we use the desktop computing, we use for the personal purpose, we use for professionals, the professionals who use personal, if you have your laptop, professionals who can be professionals, engineers, artists, authors, doctors, programmers, they use machines or the computers for their personal use. So this type of computing we call, this is what the desktop computing. Okay, and desktop computing also used in office and desktop publishing. So what the software is commonly used in desktop computing? If you have a personal laptop, what you use, in the most of the time people, they use MS Office, they use MS Word, PowerPoint, Texas. AutoCAD, the professionals basically who are the designers or the engineers. Okay, so they use AutoCAD software in personal laptop. So whenever the customer they demand like they want to have a map of their house, so what they do basically they use engineers they use AutoCAD in software for the tech, for developing these type of blueprint. So what is this? This is our desktop computing. Also many softwares like Illustrator, 3D Studio Max, Dreamweaver, Visual Studio, NetBeans, and others softwares which are used in desktop computing. Now just we are moving to the next, which is the next and very important computing, which is called client server computing. In this environment we have a one server machine and other client machines also connected with this server with the is help of the specific device. It maybe it can switch or hub. Now here you can see the this is the server machine which is in the center location, and other machines are connected into the server machine. So these are the client machine and this is what the server. Here we have one tablet also there, and one laptop is also connected. Printer is there. Here we have two printers. One backup unit device is there. So this type of model we call client server computing model. Very simple, client server computing model. And here we have the server can be like a database server, web server, application server, or different servers. It's depending on the work of the server. Like if the server is providing mail services, we call this is a mail server. If the server is providing web services, then we call this is what the web server. If server is providing the data to the customers or to the client machines, so this type of server is called data center server. Okay, so if it's depending on a services what the server is providing, we call the server with the same name. Okay, if the server is providing SMTP service, we call this is SMTP server. If it's depending on the services what the basically server is providing, we call the most of the time with the same name. Like DNS server is providing services of the related to the DNS, we call this is DNS server. This is DSCP server. This is FTP server. This is web server. Okay, like that. Now just we are moving to the next. We need to understand what the software are used when we are using the client server computing model. Client server computing model, here we have a software. The most of the time what we use accounting softwares in a center location, one accounting software is there, and the people they use from the different location this accounting software. So one server is there, other machines are client, they log in and they use this accounting software to manage the account. Sales ARP, we related to the sales. So the many companies they have outlets, their outlets in a different cities or different states. So whatever they do every day, that is updated to the server, so the company understand what is the sale of the product is going on. CRM is also like the same. Distribution ERP, manufacturing ERP also work on the same client server computing model. SAP is a software which is commonly used. Oracle apps and Microsoft Dynamics, these are the common software which are used in client server computing model. This is where you will find this computing model. If you will go to banks, you will find this one server will be there, another client machines are connected to the network. So the different employees they are working on client machines, and there you find there is a one server which is stored in a separate area. You can find it this type of network in retail store. You also can find this type of network in marketing sales. You can find this type of network in distribution of the software or application. Aviation companies you also can see in these companies client server computing model. Automobile companies you find this type of client server computing model, and all companies you will find inside of that. Now, just it is very important to understand what is client server working concept. Like here, you can see in front of you the server is there, and other client machines are connected with this server, and one laptop is also there. Here we have printers which is connected to the server, backup unit also connected, and one, two, three, four, five machines connected with this server, and this is the one laptop. So if this server machine have the capacity to manage only 5 computers, so what's the meaning of that? Meaning of that is the compute power of the server is only enough, or this server can provide the services to only 5 computers, 5 client computers. If these 5 client computers will send a request to the server will respond accordingly. It will provide services to the 5 computers. If you will increase the number of client in this machine, then load will increase on the server. And if you will continuously increase the number of machines, what will happen? It will start working slowly. And at the end, what will happen? If you will continuously increase the client machine, this server may be down. So it will stop working. So what's the meaning of that? The meaning of that is what? More clients, more load on a server. If you will add a number of clients, if you will add continuously, then it will generate a load on a server. And if it will generate a load on a server, then what is the solution of that? You need to increase the compute power of the server so that it can perform smoothly. So what is the solution? The solution is what? You need to replace this server with a new one with high configuration machine. Or the second is what? You can add one more server in this network so that these two server can manage the load of this network. Okay, now just we are moving to the next, how we can do this adding or removing, or how we can add the multiple servers in the network. We will understand in the next. Now, next is what? Here you can see the cluster computing. So it is very important now understanding the cluster computing. And in this, the first is what? The homogeneous server we are talking about. Cluster computing is what? Here, these are the 4 machines are there. But in future, you want to add more 4 machines. So you have the only one server which can manage only 4 machines, not more than 4 machines. If you will add more than 4 machines, the server performance will down, and it maybe it will stop working. Because if you are adding more client machines, then it will generate more load on a server. So this is the only server which can manage only 4 machines. And but I want to connect 8 machines in my network. So what is the solution? The only one solution is, the two solutions are there. One is what? If this is one server, here we have the with the configuration, okay, whatever the configuration which is supporting up to 4 machines, it can provide services up to 4 machines. But if we want to connect 8 machines, so what we need to do? We need to replace this server machine with a high configuration machine. So if you will leave it, if you will remove this server from here and you will go to market and you will buy a new server, so it will be costly. The second is what? This old server will be useless. You have to throw it. You have to throw it. It will be useless, old server. But and also you need to purchase a new server. Is there any solution where just we can use this old server and we can improve the the computing power of the machine, so that the cost will be less? We can go with the low cost, and also we don't need to throw any server. Yes, the one solution is what? The homogeneous server computing method here, which is called cluster computing. Cluster computing is what? Here what you can do, you can buy a one more server. If you want to connect 8 machine here, you will go to market and you will buy a one more server with the same configuration you have. In your network you have this server, and you will go to market and you will purchase a new server with the same configuration. What is the meaning of the same configuration? Like if in this machine you have ABC hardware, in this machine should have ABC hardware. In this machine you have ABC operating system. In this machine you need to install ABC operating system. In this machine you have ABC application. In this machine you should have ABC application, means that should be the new server should be the replica of server 1. That should be the same configuration server. And once you will have the same configuration server, between these servers you can use the connector by which you can do clustering between these two servers, and these two server will work like a single server for 8 machines. These two servers will work like a single server for these 8 machines. In future if you want to add more 4 machines, you will add one same configuration server here. In future you need 4 machines more, then you will add one more server here. In future if you will need more machines in your network, you will add one more server here. And just you can increase here the number of server here in this network, and these all server works like a single server. Like what you do when you want to search anything on internet, you go with Google. What do you think, Google is a single server? Not here. Here we have the data center where we have the multiple servers are there. Like here you can see here we have two server. You can add one more, 3 4 5 3 6 7 8 1000 2000 3000 1 lakh 2 lakh 3 lakh, like that. And once the server number of servers increased, this type of environment we call these are the data center servers. These two servers here you can see the works as a one server, single server. If you will add 3 server and you do clustering between these servers also works like a single server. So it is very important to understand what is clustering before understanding cloud computing. So desktop computing we have done, client server concept we understand that. What is clustering? Now just I think we got it perfectly. Now we are talking about clustering here with the homogeneous server. Homogeneous server is what? The same server configurations. If in your data center you have the same server configurations, servers are there which are connected through clustering, and these are working for a single server network environment. This is we call what? Homogeneous server, where the server configuration are the same, where we have the same hardware, same operating system and application software in all servers. Now just we move to the next, which is the heterogeneous server. This is what you can see. This is the cluster where we have, you can see the multiple computers are there. We call these are data center. And how these servers are connected? These all servers are working like a single server, like you enter google.com. So in back of the google.com, where we have the thousands and lakhs of servers are there which are providing services to the client machines. You need to understand what is grid computing. So I was talking about heterogeneous server. Heterogeneous server where the server can be different. Like this server configuration is different, this server configuration is different. This server operating system is different, this server operating system is different. This servers have a different application, this server have a different application. If this is the condition, you can understand this type of servers which have a different configuration, different operating system, application and hardware, and are connected together, working like a single server. So we call this is what the uh, heterogeneous server. This is what here you can see in presently here on the screen. This is homogeneous. If the configuration is different of the server, is heterogeneous server. Now we need to understand what is grid computing. It's very important. What is grid computing? If the servers are on different locations and one server is in Delhi and one server is in Bangalore, these are the servers working with the same company like HCL, Wipro, ABC, any company. But the server which we have in Valley, which the server have a different configuration, and server we have in a Bangalore, it's have a different configuration. And these servers basically working for a single network, one company, and these servers are connected together and providing services to the client. For example, this is a web server which is providing web services. This is the mail server which is providing mail services. But these are providing these services to the same company like HCL, Wipro, like that, and these are connected together. Okay, these are connected. This is example. Here we have two city. Here you can have 10 cities, 20 cities, like that. So this type of computing we call this what a grid computing. You need to understand this is what the grid computing. So in grid computing, already I have given you idea about that. In this, we use the heterogeneous server. Heterogeneous server is what we have. One grid server is in Noida, one is in Delhi, one is Bangalore, one is Hyderabad, and different locations we have. So in this type of servers, we have a different operating system, different application server. Okay, and these servers are used for the different purpose, like one server is used for the database server, one server is used as a mail server, one server is used as a web server, one server is used as a file server. So this type of computing we called grid computing. Here you can see the one is active directory server, file server. Okay, here we have the memories, mom server is there, ms server is there, mail server is there. Okay, these are basically what the servers, and these are working like a single server. Okay, so this type of computing we call grid computing. So we have completed desktop computing, client server computing model, and cluster computing, grid computing, and now just we are moving to the next, which is the cloud computing. Cloud computing is what the combination of clusters and grid computing. Okay, so if we connect all these clusters and grids, so this is the combination here we have. We call this is the cloud computing. I think you got it. So in this picture, you can see the multiple the cluster servers are there, multiple grid computers computing is there, and the combination of all these are what we call this is what cloud computing. Cloud computing is the companies basically who are having their own cloud computing, and some companies they have cloud computing, they are providing services to the customers. So the first is, if we talk about Toyota is a company basically who have their own cloud computing, on cloud network. Walmart is there, Tata Group is there, Citibank. Okay, these are the companies who have on cloud, and Microsoft also in this we have. Software companies also comes under of SAP is basically cloud computing. They have their own cloud, Oracle app, Microsoft Dynamic. Infrastructure maintenance companies also have their cloud, IBM cloud, Dell cloud, Intel cloud, HP cloud, Cisco cloud, Sun Solaris cloud. So these are basically the companies they have their own cloud and they are using the cloud computing model. Evolution of cloud computing is what you need to understand. That is what the started in. That is possible because of only of the ARPA, Advanced Research Project Agency, which is given the protocol system. Okay, it is, they are responsible for the internet nowadays we are using. They are also responsible for TCP/IP. They introduced this in 1970. ARPANET, Advanced Research Project Agency. They started survey of just connecting machines in a large distance. History of internet, if we talk about, the project started in year 1969. Email server was introduced in 1972. World Wide Web born in 1991. So we are starting internet or the websites from 1991. Now if we talk about what is the difference in email and web page. Okay, it's very important. The people, they do not have idea about what is the difference in mail and web page. Mail is what? Mail is basically the communication. You want to send one information to other one, and this type of the messaging called one to one. If you are sending an information, that will come to me only, not to others. So this type of information exchange or the communication is what one to one. But if we talk about website, this is one to all. It is just like uh, a notice board where you put anything, anybody can check it, anybody can read it. This is what the website. So you need to understand difference between website and email. Now you understand with the new things, a server in internet. So what the servers, if there is one server is there, and if you want to access the service of this server, like one web server is there, so who can be the client of this? Any computer machine which can connect with this server with the help of internet. PDOs, personal device, okay, laptop, personal computer, and they connect with the internet, and this internet gives the access to the web server, and web server have a database from where they provide this information to the client. This was the, it can be a private network server in intranet, where just we have the private network. This is what the server into intranet. So intranet is basically what, it's working like a internet, but here the public users, they cannot use this network. They have their private users, private clients, and this is used for the personal, for the company. They work like the same as working on internet, but that is what the private network, completely private network. You cannot directly access these websites or web services of the server. This is what the totally private network, where they work like the same as internet. Internet is a public network where anyone can connect to the public, okay, and they can easily access uh, all the data which is available on the public network. Private web server, here the private web server is the server where the private companies, they have the information is stored on website. That is private web server. And if you are using the some services like if you will go to search anything on Google, this is what the public web servers also there. Hosting service provider there for the website. If you are generating your website, if you want to start your website, you need to have a hosting services, and you need to have uh, also you need to have a domain name, so you can purchase it with the service providers. Like some companies are also there which are providing services like cloud. GoDaddy is also there. So GoDaddy, you can go with this website, from where you can have a hosting space. DreamHost is also there. Bluehost is also there. You can purchase it from that location. Multiple website on a server. on a single hosting server. You can have the multiples websites are there, because here the servers we use for the hosting only. So if you have a website, you take a space on a server and you store it on the server, you upload it on the server. So whenever any user want to access your website, they enter the domain name, and this domain name basically resolve the name into IP address, and IP address have a specific address of the server. From this server it will upload it to the network, and it will give you response according to the website you have uploaded on the server. This is what the hosting service, and the many companies they are providing hosting services. Okay, meaning is what, like they have the storage capacity like 20 GB, 30 GB, 1 TB, 20 TB, 100 TB, like that. Okay, so what they are giving this space on a web server to the client for a specific time period. Like you can buy 1 MB space or 20 MB space or 50 MB space or 1 GB space on my server for 1000 rupees for a 1 year. After 1 year, then it will not work, you have to pay for that. So what I have done, I am giving my storage capacity to the users on rent. This is what I am giving this storage, where they can upload their website on my web server, and this is used for the hosting, and they charge for it for a year, 2 year, 3 year. Okay, once if the agreement is complete, then after that you need to pay again for that. So this is what they are giving on rent. Now just we are moving to the next. Here we have the different type of hosting is there. One is a shared hosting, and the second is virtual private server. Shared hosting is what? One server is there where we have the hardware, simple hardware. Operating system should be there, Linux or Windows, anything. A web server, if we are designing this for a web server, so that means we can have the web services on this operating system. This can be Windows 2016 web server, like that. And in this we can upload multiple websites. What is a virtual private server? In this we have hardware. In hardware we are using the different virtual platform. This hardware we are using virtually in different part. So like operating system 1, operating system 2, operating system 3, and these three virtual operating system works like a three machines. And in these three machines we are having the different websites. These servers are managing, these operating systems are managing these website as a machine. And in this we have a dedicated server, which is the only responsible for a single website. We call this is what the dedicated server. Now we are moving to the next. What is the way of growth of content? Everywhere now it's very important. Now the companies working on AI, artificial intelligence. What they need content. They are feeding content to the software so that if any question will come, it will reply accordingly and perfectly. So what they need content. Also, if we talk about Google, when you type anything on Google, you find the result. How? You know about that? How you are getting the result? Google have any idea about that? No. The people what they are entering on the Google is learning from the people. When you write my name is Rahul, Google understand Rahul is a name. When you type some information on Google, that stored it into database. When other people they ask about that, that will search it from this database, and it gives you the relevant answer to you. So what is the meaning of growth of contents? Contents plays key role in internet. So whatever you enter on internet, it's learn, it's understand. The next time you ask, it will give you the answer accordingly. What is the source of growth of content? Let internet users write the content. What the content they write? That is the improvement or the growth of the content. And after some time, when they will ask from the Google or any other site, it gives the information from this uh, content which is written by the users. Internet as a cloud, if we talk about the what the internet, the services which are provided in the cloud services, here we have Google uh, cloud services also there, Salesforce cloud services also there, Microsoft cloud services also there, Juhu, Yahoo, Amazon. Many companies are there who are providing the cloud services. Now here these are basically the companies who are providing, they have their own cloud. Basically they have their own cloud, and these are basically internet as a cloud. And here we have, these are the companies who have their own cloud. Okay, so their private cloud they have also. Internet as a cloud, if we talk about, these all companies have their cloud and decided to provide on rent. Like one company, Azure, this is what the Microsoft cloud, Azure, and they are providing these services to the client on rent. Okay, where you find virtual machines also. Amazon is also there, NetSuite is also there, GoGrid is also, entity communication is also, 3 tera also used. Okay, uh, Rackspace. Okay, salesforce.com, Google, open source. So these are the companies here you can see. Data in cloud. Data in cloud is what? So we have the number of data centers. I think you know about the data centers. So whenever one database server is there, whenever any application desktop uh, enter any request to the server, and server is connected to the data center. From data center it takes the reply, and it's basically replicate with data center database server. Okay, and it's reply to the client machine. Here you can see, this is the example. Cloud as a business, cloud services, what the cloud services are available. So the here you can see, firstly we need to understand the flashback. Here we have two type of clouds are there, private cloud and cloud in internet. So private cloud, Toyota, they have their private cloud, they are not providing any services to anyone. Citibank, they have their uh, on cloud. Walmart, they have their own cloud, and many companies they have their own private clouds. But some companies basically who are giving the services to the customers, so these are clouds in internet, like Google is there, Microsoft is there, Salesforce is there, HP is there, IBM is there. I think it is clear to you. And in simple term, if anybody will ask you what is cloud, then you will say the cloud is equal to cluster plus grid. Clustered network, grid network, the combination of this network is called cloud network. Web hosting, I have given you idea about that, where the people they give the free space to the users for the website. These type of servers are called to the web hosting. Now it is moved to the application server on rent. Okay, here This is what the rented share hosting for website, but now the people they are having complete server on rent. So application server on rent, okay, rented cloud for client server model, business and application. It concept is the same. Server basic requirement here, database server is there. In this we need a hardware, network, hardware, operating system and application. In a computer we need these things. So we need to have a hardware, we need to have a uh, operating system, we need to have application software. So hardware, network is what this is, we can say the infrastructure. Operating system we can say the platform. Application it can be like software and ERP. These are basically three part of any system we need to have. Hardware we need to have, which is called infrastructure. Operating system we need to have, which is called platform. And application which is we need to have, which is called the software. So these three things we need to have. These are the server basic requirements. Here you can understand this is what in a simple method. If you will go to book a banquet hall for your brother marriage, in this you will get three options. If you want just space, the costing of this will be low. So you can say to the owner of the banquet hall, we need to have only space where the decoration and the catering part you will manage at your end. The second, you can go with space and decoration in banquet hall. So you will say to the owner, you need to provide space and decoration. We will manage catering. Third is what? Here you can have space with a decoration and catering. This is what the complete solution you are asking from banquet hall owner. So here you can see three categories are there. First is what you need to have just space. In second, you need to have space with decoration. Third, in this you need everything. You need to have a space, you need a decoration also, and you need a catering food also, okay, to serve to the guest. So this is what here you can understand these three types of the cloud services here we have. One, if we are talking about just space, this is what we are asking for infrastructure only. If we are saying space and decoration, then we are asking for infrastructure plus operating system. So that means we need a platform. Third is what? We need space, decoration and catering. That means we need a complete solution. And this is what SaaS, software as a service. So this we are moving to the next. So this we can divide in three categories of the cloud services. Choice for cloud servers. The first is what? Just infrastructure. It is just like a blank, or you need to have a space banquet hall, only space, you don't need anything in. So this type of service we call IaaS, infrastructure as a service. IaaS, it is a just infrastructure. So the many companies they are providing infrastructure, they provide the compute only, they provide you virtual machine where they will give you only CPU, RAM and storage and the network device. What you have to do, you need to install operating system in it, you need to install application in which you want to work. This is your part. But what the service cloud service provider will do, they will give you only the machine in which you have the hardware compute power. Next is what AAS, you can say the PaaS, which is called the platform as a service. Platform as a service is what? Infrastructure plus platform. Infrastructure plus platform is what? Infrastructure is the same hardware, plus platform is what? What type of platform you want to use? Like you want to use Windows platform, you want to use Linux platform, you want to use Unix platform, you want to use Sun Solaris platform, you want to use the different platforms are there. So what they gives, they you can say I want i3 computer with server 2003 operating system. I want i9 computer with server 2019 operating system. So this type of service, if any service provider will give you, we call this is what? PaaS, platform as a service. Then next is what? SaaS, SaaS, software as a service we call this is. In this the cloud service provider will give you infrastructure, what is according to your requirement, platform according to your requirement, and software according to your requirement. Like for example, you need i3 machine, this is what the infrastructure. You need a Windows 2016 operating system, this is what the platform. You need MS Office application in my machine, this is what the software. So this is what the complete solution. So you can say the clouds are divided in three categories: IaaS, PaaS, and SaaS. Infrastructure as a service, platform as a service, and software as a service. So these are three categories of the uh, cloud. So in this we have a practical, you can do this in a virtual lab, okay, where you can easily understand. So little part of that I'm going to tell you here. Like let me open VMware, so you will see this VM, VMware workstation I have in my machine. These are the virtual machines you can see. Okay, so one virtual machine I have Windows 7, Windows Server 2012, Kali Linux. These are the operating system in my machine. VMware workstation. These are the virtual machines. You can create here virtual machine also. Okay, so I will explain about that in the next session, and you can write in comment if you want to know about that, how we can create machine in virtual VMware workstation as a virtual machine. Okay, let's we move to the again to the PPT so that we can continue. Here we have some cloud service model. Here you can see the infrastructure as a service, platform as a service, and software as a service. Infrastructure as a service, and Amazon provide that infrastructure as a service, rent, processing, storage, hardware, networking capacity, computing resources. In this you will find the platform as a service, PaaS, deploy the customer created applications. In this you will have a software as a service, provide the applications. Okay, so like a very simple example is Office 365 is a very good example of SaaS. Here you can see. Okay, now just we are moving again to the PPT so that we will complete it very fast. So this is all about the cloud computing. So I think you understand what is the cloud computing. What is cloud computing? Delivery of computing services over the internet, including storage, processing, and database management. In this, basically, they provide the flexible resources, rapid innovation, and economic of scales. So you can, it's like, for example, you have to pay to the cloud service providers as you use. It's depending the machines. If it's depending on the uses of the machines, you pay according to use. Using an online service like Amazon's Web Service, AWS, to host virtual servers, database, and application that scale on demand with business needs. So, in simple terms, you can say nowadays the basically entry of cloud computing is the game changer. Cloud computing that delivers computing services over the internet, from storage and database to AI and analytic on demand like utilities. No more maintenance, no more maintaining bulky servers and like that at your home, at your place. You don't need to buy any server. Just scale and go. This is what cloud computing. Next is very important, which is the microservices architecture. Microservices. What is microservices? In the cloud era, we use microservices like small independent services that perform a specific business function. They are easier to develop, test, and scale compared to monolithic application. Think one server or one service handles payments, another handles user login, all communicating via APIs. This is the only single example of microservices. An architecture style that structures an application as a collection of loosely coupled services, each implemented specific business capabilities, like an e-commerce platform where the user interface, payment processing, and inventory management are separated. Independently deployable services that communicate over a network is these type of services are called microservices. Cloud service model, already I have given you idea about that, provides the virtualized computing resources over the internet. PaaS is platform as a service, so for hardware and software tools over the internet, typically for the application development. SaaS is what delivers the software application over the internet on a subscription basis, like accessing email through Gmail or any other. You are connecting to the document, and just you are using Office 365 is example of that. PaaS is example of using a Microsoft Azure to develop, run, and manage application without the complexity of building and maintaining infrastructure. And IaaS is nothing, it's rental virtual machines, VMs, you can say that, and store from providers like Amazon, EC2, or Google Compute Engine. These are basically the IaaS service provider. These are the basically cloud service model. Here we have some provisioning already I have discussed in the last. You can go with this provisioning, customer impact, and security consideration for that. Anything as a service, it is very important. So in cloud service models, I have given you idea about these are of three: IaaS, PaaS, and SaaS. IaaS is infrastructure as a service. AWS, EC2 is the example. PaaS is platform as a service. Google App Engine is the example of it. SaaS is what? Software as a service. Microsoft Office 365 is the example of that. Anything as a service is what? XaaS. We call this is XaaS. This is what anything as a service. Going further, everything is now as a service. From database as a service to AI as a service. This flexibility means the businesses can innovate faster and pay only for what they use. This is what anything as a service. So you need to pay only for what you use. If you use a machine for 12 minutes or 30 minutes, you need to pay for this only. It's, it's like pay only for what you use. If you use any machine for 3 hours, you need to pay only for 3 hours, not more than that. It's enough. So you can easily understand anything as a service is a delivery model where the various services and applications are provided over the internet, allowing users to access technology services on demand without owning the underlying infrastructure like desktop as a service, storage as a service, security as a service, function as a service. Cloud provide offering disaster recovery service online, enabling business to implement the backup solution without their physical data center. Share a responsibility matrix. Here it is very important to understand. So what is this? This is here we have cloud deployment models. We need to understand first. The cloud client deployment model is important. Public cloud is there, private cloud is there, hybrid cloud is there. Okay. So these are three categories of cloud is public cloud, private cloud, and hybrid cloud. Public cloud is what? Shared, cost effective and scalable. Private cloud is dedicated, more secure and costly. Hybrid cloud is a mix of both. One cloud is also there which is called community cloud. So community cloud is shared by specific organizations with a common concern. This type of cloud is called community cloud. Now these are basically here we have some task details and responsibilities are there for IaaS and PaaS and SaaS. So most of the part we have discussed. We are moving to the next. Cloud deployment model, I have given you idea about that also. Public cloud, private cloud, hybrid cloud and community cloud. Now this is very important, cloud bursting. Cloud bursting is what? Cloud burst. This is you can say the configuration setup where an application runs in a private cloud or data center and bursts into a public cloud when the demand for computing capacity spikes. Or you can say it is, let's provide a cloud tab into public cloud when the demand exceed capacities, offering the flexibility and cost control. This is called cloud burst. For example, a retail website operates on a private cloud but uses cloud bursting to access additional resources from a public cloud during a holiday sale, even ensuring the website remain responsive under heavy traffic. It is just like that you are having your a website which is in a private cloud, but the capacity of the private cloud is limited. In case if the heavy traffic will come, it will automatically move to the public cloud. For that, you need to add some additional resources. For this, you need to add the bursting uh, feature with that cloud burst. Then it will work. Here we have the different model of cloud bursting: distributed load balancing, automated bursting, manual bursting. These are basically different models are there, and different techniques are used in this to provide the support. Like if we distributed, if we talk about, this is what the global content delivery network that routes users request to the nearest machine. So this is what the load balancing is there. If we talk about automated, it is basically work like for a e-commerce company or platform automatically scale out to cloud resources during unexpected traffic spikes, like a viral product launch. The next is what the manual bursting is, that very simple. If an IT staff manually activate the extra cloud servers during the planned high traffic events such as an online conference or major product release. These type of three categories are also there. Here it is very important what is on premises and versus cloud provisioning. This is if you have your services on premises. Okay. Aspect is there what the initial cost, scalability, maintenance, control, security, deployment speed, accessibility, and customization. On premises, everything will be very costly. But that means if we talk about the uh, initial cost, it's very high. It's high upfront investment in hardware and facilities. You need to arrange everything at your end. If we talk about scalability, limited scalability is there, limited by physical resources. Scaling requires additional hardware and space. Maintenance, full responsibility of the maintenance, update, and hardware issues. You need to do everything at your end. Control, complete control over hardware and software and security setting, because this is in your premises. Security, total control over the security measures, but requires the significant expertise and resources to implement effectively. Deployment speed is deployment can be time consuming due to physical setup and configuration. Accessibility, typically accessible only within the organization's network unless the specifically configured. Customization, highly customizable to specific business needs. But if we talk about cloud provisioning, here the low initial cost is there. Pay as you go pricing model. Scalability in this also, easy scalable resource can be adjusted dynamically according to demand. If you need 5 machines today, you can go with 5 only. If you need 2 machines only, you can go with 2 machines. Scalability is there. Provider handles the maintenance, update, and infrastructure. This is what related to the maintenance. Easy in maintenance, you don't need to worry about that. Control, less control over infrastructure dependent on the providers offering and policies. They manage everything. Security managed by the providers with the they provide everything. Compliance, according to compliance, they provide the security according to regulatory standards, but share the responsibility for data security. Deployment speed is a rapid deployment. as resources as a provision aimed instantly over the internet. Accessibility from anywhere with the internet connection and enhance the flexibility. Customization, limited customization option based on what the provider offer. You cannot do anything in it. Cloud infrastructure, the combination of hardware and software component such as server, storage, network devices, and virtualization software, and needed to support the computing requirement of a cloud computing model. This is what the cloud computing or cloud infrastructure. And for example, an organization uses Amazon website, which provide the virtual server EC2, storage S3, and networking capabilities like VPC that together from the cloud infrastructure, allowing for the scalable and flexible application deployment. Cloud characteristic, here you can see the on-demand service, board network access, resource pooling, rapid elasticity, measured service, multi-tenancy, scalable and flexible. So these are what the characteristic of cloud I already have explained to you. Now next, cloud security group. Cloud security group is uh, you can say a virtual firewall that controls inbound and outbound traffic to network interfaces and instances within a cloud environment. They define rules that allow or deny the network traffic based on IP protocol, port number, and source and destination IP addresses. This is what related to the cloud security group. For example, Amazon server is there. A security group can be set up to allow the traffic only on port number 80443 from any source IP address, effectively allowing the web traffic to reach web servers while blocking all the other form of traffic. This helps to minimize the potential attack surface on cloud instances. Cloud containers, what are the cloud containers? Containers like Docker. Docker is container, you can say that. Docker means bundle app with their dependencies, ensuring they run anywhere from a developer's laptop to the cloud. Lightweight executable unit of a software, you can say, in which the application code is packed along with its libraries and dependencies in common ways so that it can run anywhere, whether on desktop, traditional IT, or the cloud. So containers what? Docker. Docker container are commonly used in cloud environment to deploy applications. A software deployment or if you are developing any software or any company which is basically developing which working on development software development might use the containers to package and deploy a web application, ensuring it run constantly across multiple development and production environment, irrespective of underlying hardware or cloud infrastructure. This consistency simplify the development, testing, deployment, and scaling process. This is what the cloud containers. Now, we need to understand cloud geographical concept. Cloud geographical concept is what? In simple terms, you can say that cloud resources are hosted in a region and availability zone. Distributed data centers that ensure the fault tolerance and low latency. So here in this we need to choose, or you can say that choosing the right reason impact compliance, speed and redundancy. This is very important. So reason is there, availability zone is there, age, location, data uh, severity, geo. You can say that the redundancy is also there, geo restrictions also there. These are what the description of that. High availability is what? Ensure that the cloud service or application is available without significant downtime. There is no downtime. This is what we call high availability. Using multiple load balancer servers that can handle request even if one fail, the minimize the service interruption. This is called high availability. And what do you mean by the data center? It is very important. So modern data centers are smart. In this, uh, already I have given you idea about that. I think data center server. Fault tolerance. What is the meaning of fault tolerance? Ability to, you know, to have a backup of anything. This is what the fault tolerance. The ability of a cloud system to continue operating without interruption even when one or more of its components fail. Like implementing redundant instance of the critical components such as a database so that if one fails, other can uh, seamlessly take over its duties without affecting users. It will run smoothly. Right, the rate terminology is also example of that. Data center automation is what? Now the data centers are smart. Automation enables auto scaling, self healing, provisioning, and configuration through tools like Terraform, Ansible, and Kubernetes. This reduces the human error and speed up the deployment. This is what data center automation use. Now just we are moving to the next, virtualization. Okay, the demand generated resource allocation is what? Demand generated allocation is very simple. A system design where the computing resources are dynamically allocated based on a real-time user demand on application request. Like in some cloud services, we have cloud service. This is the, you can say that is a cloud service automatically scale up additional server instance during a spike of a website traffic. If your traffic on the website will increase, then it will improve the uh, scale of your server. It will add more server in this. If it's the traffic is coming, more traffic is coming, it will not let the server down. It will scale up with additional servers or instance during any spike in website traffic. This is what resource allocation, demand resource allocation feature. This is you will find inside of cloud services. Scalability and elasticities. These are the we can categorize in two part. Scalability is what? The ability of a system to handle the increased workload by proportionally increasing its resources. Adding more servers to a database cluster to handle increased user queries as an application gains more users. Elasticity is what? The ability of a system to automatically adjust and allocate computing resources based on the current demand. A cloud computing service that automatically adds more computing resources when the traffic to a website peaks and reduce the resource when the traffic declines. So it is basically it's depending on optimized cost. Solution element survey. infrastructure as code, IAC is there, serverless computing is also, and microservices. So first, if we talk about infrastructure as a code, which is IAC, managing and provisioning computing infrastructure through the machine, readable definition file rather than the physical hardware configuration. It's we use in this Terraform script to automatically set up and configure virtual server, network, and storage in AWS. It is just like answer file. Serverless computing is what? A cloud computing model where the cloud provide or the cloud provider manage the setup capacity, planning, and server. They provide the server capacity planning and server management. Developers write and deploy the code that runs in the stateless compute container that are event triggered, like AWS Lambda automatically run code in a response to multiple events such as a HTTP request via Amazon API gateway without provisioning or managing servers. So microservices, here we have an architectural style that structure an application as a collection of loosely coupled services which implement the business capabilities. So this is what related to the solution. Here we have virtualization we have discussed. This is also comes under the solution element survey. Containerization, also in this we have software defined network comes under of it. Now just we are moving to the virtualization. Virtualization is a, as you can say, it's a technique or it's a technology that makes cloud possible. It creates a virtual instance of physical hardware allowing the multiple OS and apps to run on a single machine. So it is nothing, it's not more than a technology that's allow or to creating a multiple uh, simulated environment or dedicated resources from a single physical hardware system. In this we have the multiple benefits: resource efficiency, cost reduction, improve management, uh, increase the availability, also enhance the disaster recovery. In this you will find type of virtualization: server virtualization, desktop, storage, and network. Server is basically divides one physical server into the multiple isolated virtual environment. Desktop is what the separate the desktop environment and the associated application software from the physical device used to access it. Storage is what the pools physical storage from multiple network storage device into a single storage device that is managed from a central console. Network type of virtualization is creates a virtual version of the network resource independently from the actual hardware. So these are basically a type of virtualization. Now we are moving to the next, which is very common. We call this is hypervisor. You find this hypervisor in Windows operating system. You can configure it. So hypervisor is nothing, it's a software, firmware, or a hardware that create and run virtual machines by abstracting the physical hardware and allocating resources to VM environment. Here we have two type of hypervisors, type 1 and type 2. Type 1, also known as a bare metal hypervisor, it runs directly on the host hardware to control the hardware and to manage guest operating system. This type of offers the best perform and is used in the enterprise environments. Type 2, also known as the hosted hypervisor, it runs on a conventional operating system like Windows Server 2010, 12, just like other computer programs. It is easier to set up and ideal for the personal use or less resource in intensive applications. So type 2 you use basically you can use in server operating system. It is you can configure into server operating system also. Desktop virtualization, it is a technology that separate the desktop environment and associate software from the physical device that is used to access. In this we have the persistent VDI is basically each user gets their own virtual desktop instance which retain all the personal setting and data even after the user logout. In employee logs into their virtual desktop from the home and personalize the desktop background and application shortcuts, these changes are saved and appear during the next login regardless of the access device because these are saving storing on server only. The second is what non-persistent VDI provides an uniform desktop environment to every user each time they log in. So the personal settings and changes are not saved once the user log out. It will remain same. Every next time he will log in, he will get the default setting. Virtualization concept, you can see here we have two virtual machine. Escape virtual machine is proven. So what is virtual machine escape is the security breach where an attackers gain access from the within a virtual machines to the host system or other VM running on the same host. But sprawl, what is sprawl? That is occurs when the number of VMs on a network grows uncontrollable without proper oversight leading to management difficulties and increase the security vulnerabilities. For example, an organization loses track of active and inactive VMs, leading to the neglected security updates and patches, which increase the risk of the malware infections and data breaches. Very important, which is called embedded system. Embedded system is what? So most of the examples you can see in your house in digital watch we have embedded system, in microwave we have embedded system, in washing machine we have embedded system. You can say it's a combination of computer hardware and software and perhaps the additional mechanical or other parts designed to perform the dedicated function. Often embedded systems are part of the part of a large device like home thermostat that uses sensor to detect the temperature change and automatically adjust heating and cooling setting. Embedded system is in this context are specifically designed to manage, monitor and control the environment conditions in a home efficiently. In washing machine, you set this will wash 1 hour, 1 hour 30 minutes it will take to wash, and you start play button. Here we have the securing embedded system, minimize the attack surface, secure boot, regular update, hardware security, data encryption, access control, network security, physical security, audit and monitoring, and vulnerabilities and management. This is what related to information about it. Limit the system capabilities and services to those necessary for function to reduce the potential vulnerabilities. So these are the points here we have by which we can secure the embedded system. Here you can see the embedded system. So very good example is LAN card in your machine where we have the embedded chip in which we have the MAC address. It's very simple example. Also we have the example, if you will have you have a automatic washing machine, in this you will have, if you have microwave you will have in this. Okay, so these are basically what the embedded system, hardware plus software. It's a is programmed, a hardware which is programmed with the software is an embedded system. Internet of the things, we call this is the IoT, connects everyday devices like sensor, okay, like smart appliances, and these appliances to the, we are connecting to the internet, and these are basically collecting like exchanging data in real time, like live camera is there, CCTV camera, internet of the things, a network or physical object embedded with sensor, software and other technologies for the purpose of connecting and exchanging data with other devices and the system over the internet. If you have a CCTV and you are accessing the CCTV in another location through internet, a smart home system where the devices like thermistors, security cameras, and refrigerators are connected to the internet, allowing users to control them remotely via the smartphone and voice commands. This connectivity enables the automated adjustment, monitoring, and management, enhancing the conventions and effective efficiency in the everyday life. These are the component of IoT: sensor, device, connectivity, data processing, user interface, actuator, gateways, cloud servers, and security. Example of IoT: home automation, healthcare, industrial, architecture, retail, transportation, energy, and smart cities. Home appliances or home automation, smart thermostat is basically a very good example of that. Healthcare, remote patient monitoring is a basically healthcare IO application. Industrial, uh, predictive maintenance is what which is in IO application now. Agriculture, the smart farming, retail, smart inventory management, transportation, flood management, smart grid, which is the energy, smart cities, traffic management. These are very good example of IoT. IoT vulnerabilities ensure web interface, insufficient authentication and authorization, insecure network services, lack of transport encryption, privacy concern, insecure software and firmware, poor physical securities inside ware. Edge computing. What is the meaning of edge computing? Edge computing, you can say, it's a processing data closer to the secure instead of the centralized cloud. This reduces the latency and bandwidth uses. Or you can say it's involved the processing data near the edge of the network where the data is being generated instead of in a centralized data processing warehouse. In a smart factory, edge computing devices process data directly from manufacturing equipment on the shop floor in real time, enabling immediate analysis and response. This reduces the latency, decrease the bandwidth use, and improve the system efficiency by handling data locally rather than the sending it to a distant cloud or data center for processing. So this is what all about the session today. We have completed most of the part. In the next, we will learn about domain 4, and before that we have some topics we need to cover, and once we will cover, then we will go for the next. I hope you will see everything carefully and you will understand that. If you will have any doubt, you can write in comment. I will explain to you, and we will be online on Saturday. So if you have any questions and doubt related to the topic which we have covered, you can discuss with me. Till the next session, bye everyone. See you in next topic.